Hi everybody, in this video we are going to start section 4 of chapter 4, and specifically we're going to talk about combinations and permutations. This is a subset of a much larger topic called combinatorics, how the science of counting objects in a collection. First we're going to introduce the idea of the factorial, and we're going to use that to describe to describe permutations, i.e. the number of ways that you can actually arrange or order a subset of objects from a collection of objects. And in a subsequent video, we will talk about combinations. And through this, we will show you how technology, namely your calculator, can actually compute these for you. So first we're going to start off with factorial, and this is the formula for it. Looks a little daunting, it's not that bad. Of course, we also have a more compact version of it where we use the large Greek symbol pi, which is the multiplication symbol. And basically what we're saying is that n factorial is going to be the product of all the numbers starting from 1 all the way up to n. So what do you need to know? Well, just follow this example and this will tell you everything. 4 factorial is 4 times 3 times 2 times 1. N times n minus 1 times n minus 2 times n minus 3. As far as you need to go as far as that's concerned. 5 factorial, you guessed it, 5 times 4 times 3 times 2 times 1. 100 factorial, you can see that in your mind. It's going to be 100 times 99 times 98 times all the way down to 1. That's all there is to it. Okay, so let's go ahead and do a couple of computations. Here is our first one, 5 factorial. That will be 5 times 4 times 3 times 2 times 1. 5 times 4, well, that's 20. So 20 times 3 times 2 times 1. 20 times 3, well, that is 60. 60 times 2 times, well, let's make my 2 back, there we go, times 1. And then 60 times 2 is 120. And then 2 times 1, and then 120 times 1 is 120. So we have that 5 factorial is 120. What about 6 factorial? Well, that is going to be 6 times 5 times 4 times 3 times 2 times 1. Okay, we already know that this right here, hey, that's 120. So this is going to be equal to 6 times 120, which is equal to 720. Okay, so for relatively small numbers, it's pretty straightforward. And also notice, if you know the factorial of a smaller number, you can leverage that to compute the factorial of one that is slightly larger. 0 factorial. Well, 0 factorial based upon our definition makes no sense, but we define 0 factorial as being equal to 1. And the next one is 69 factorial. I cannot do that by hand. That would be 69 times 68 times all the way down to times 2 times 1. I can't do that. But that's okay. That's why we have calculators. And here's my calculator. Now, if you want to do this using your calculator, this is what you want to do. First thing is type in 69 or enter 69. Okay. Then go to math. Go over to probability. So we want to use this button right here to go over to probability. Okay, there we are, PRB. And notice the exclamation point. That's what we want. We just want to go down to 4 or hit 4. And there we go, 69 factorial. Hit the button. And that is our answer. Notice that answer looks a little weird. It's 1.71 with all this other stuff, e to the 98. The way that would be written is as follows. 1.71, and the e stands for times 10 to the 98. That is what we call exponential notation. The e basically means times 10, which essentially means that you would want to move this decimal place 98 places over to the right if you wanted the regular floating point answer. Okay, and then finally, we have 70 factorial. So let's go ahead and do that. Well, we have 69 factorial here, right? So what we could do is just do times 70. And we get an error overflow. Why does that happen? Why does that happen? Well, let me go back to GoTo and go up a little bit. There we go. Because in the exponent place right here, in your calculator, can only go up to 2 digits. If it gets any higher, it overflows and you can't get it, and you will get an error. Now, if you used your calculator on your computer, it turns out that they support more than 2 decimal or 2 digits in the exponential field. You can actually get a number. If you wanted to try this using the factorial feature again, let's just go ahead and let's go down and do that. You can do 70 math over the probability factorial, and once again you get your overflow. As I mentioned before, you can do this on the calculator in Windows. Here is the Windows Basic Calculator right here, and I could do 70. Here is a symbol for factorial, and that would be your answer. That would give me 1.20 times 10 to the 100th. So this actually is 1.20 times 10 to the 100th. So you can't do this on your TI-84, but you could do this on your Windows calculator. Really, you don't have to worry about it. We're not going to be doing numbers that high. Okay, a couple more examples. For example, we want to compute the following. 5 factorial over 2 factorial. That is going to be equal to 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Conveniently, the 2's cancel, the 1's cancel, and you just simply have 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. Next, we have 6 factorial divided by 4 factorial. 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. All these cancel. This is nothing more than 6 times 5, which is 30. And then the third example, which is something you're going to see in the subsequent video, this is actually called the combination computation. This will be 6 factorial divided by 2 factorial, and then 6 minus 2, that is 4 factorial. Okay, so that's going to be 6 times 5 times 4 times 3 times 2 times 1. Turns out 2 factorial is just simply 2. 2 times 1 is 2. Times 4 times 3 times 2 times 1. Of course, these cancel again. And then this is going to be equal to 30 divided by 2, which is 15. Now let's talk about permutations. Permutations is the selection of distinct objects where order matters. So if you had distinct objects, i.e. objects that look differently, and you want to grab them and pay attention to how they order, this is the number of ways these are the number of possible ways that you can actually select those objects where order matters. For example, here I have three distinct objects, 1, 2, 3. How many ways can I select all these 3 objects? In other words, how many permutations do we have? Well, here they are. We can have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. There are no other ways. And it turns out that there are 6, or 3 factorial. So that kind of gives you an idea of how we might want to compute these. Well, here's another one. Here I have 5 objects, 1, 2, 3, 4, and 5. I guess we could say those are distinct. And we want to select 2 of those objects out of this collection of 5. How many ways can we do this where the order actually matters? So here we go. 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2, 3, 3, 3, 5, 4, 1, 4, 2, 4, 3, 4, 5, 5-1, 5-2, 5-3, 5-4. There happen to be 20. Ironically, that is also equal to 5 factorial over 3 factorial, or 5 factorial over 5 minus 2, because remember we were selecting two objects. And that kind of gives you some insight as to the formula for coming up with the number of permutations, or the number of ways of selecting R objects from a collection of N objects where order matters. In this particular case, we have a total collection of N objects. And we want to know the number of ways we can select 2, or R, which is 2 objects, where order matters. And that turns to be N factorial over N minus R factorial, where N is 5 and R happens to be 2. And that brings us to our definition for permutations. Suppose we have N objects. Suppose we select R of them. Suppose that order matters, and the number of permutations is given by this particular formula. It is also defined by this signal right here, or this symbol right here. Okay, once again, it is nothing more than N factorial divided by N minus R factorial. So let's take a look at this example. A doctor visits her patients during morning rounds. How many ways can the doctor visit 4 patients during the morning rounds? So the doctor has 4 patients and she wants to select all 4, and the order actually does matter. So this is a permutation problem, so it's going to be 4p4. Now remember, NPR is going to be N factorial divided by N minus R factorial. In this case, it is going to be 4 factorial divided by 4 minus 4 factorial, or I guess I should say factorial, which is nothing more than 4 factorial divided by 0 factorial, which is just simply 4 factorial, which is 4 times 3 times 2 times 1, or 24 ways. There's actually 24 ways to do this. Now, you can go through this, or you can actually have your calculator compute this for you. How can you do that? So let's go ahead and bring our calculator up. Okay, let's get rid of all these errors. And what we want to do is, the first thing we want to do is we want to put in our 4. Then we want to go into math. Go over the probability. See here we have NPR. Highlight that. That happens to be a 2. Hit, and okay, there it is. And now put in your other 4. Hit enter. And there you go. We have 24. So that is actually how it's done on a TI-84 Plus. If you have one of the more advanced ones, the Plus CE, it will look like this. Pretty much the exact same thing. Instead of putting in the 4 first, just go to math, go over to probability, hit 2, and then in this little subscript, put in 4. Move the cursor over to the other subscript, put in 4 again, and there you go, you have 24. In our next example, we have a coordinator. We'll select 5 songs from a list of 13 songs to compose an event's musical entertainment lineup. How many different lineups are possible? Now, this is also another problem where you have to discern that order matters. So this is a problem for permutations. Okay, this will be 13p5. What would that look like by hand? Well, that's going to be 13 factorial divided by 13 minus 5 factorial, which is going to be 13 factorial divided by 8 factorial. And if you actually did the math, this would or if you actually expanded these and canceled, you would have 13 times 12 times 11 times 10 times 9, whatever that happens to be. Or you can go ahead and use your calculator the way we've done it before. So let me bring my calculator up. We can type in 13 math over the probability 2 for NP, put in 5, and we get 154,440. Also, if you did 13 times 12 times 11 times 10 times 9, you get the exact same answer. And that is all that I have for this particular video. Stay tuned for a follow-on video when we will talk about combinations and this thing called the binomial coefficient. As always, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.